in the data privacy and security arenas. I just saw this on Meetup. It looked interesting. So just making use of my time this afternoon.
Cool, very cool. So thank you everyone for joining us this Friday. We'll just go ahead and get started. So today we'll talk about cloud security, but people when people start, and even like everyone mentioned earlier, cloud is like hot topic and everyone is like conscious about cloud security in certain ways, least privilege, IAM, but also from data perspective, that what all things can you do on data controls and data security and such. So today we'll try to cover some of the cloud and endpoint security, but also try to give you a holistic view of like what actually cloud is, like do some of the basics, and then we'll go into details about what all things comprises in security across like cloud providers, whether you use AWS, Google, or Azure, or Oracle, or Alibaba, if someone here is using that as well. So we'll try to go over comprehensive across the providers, see some of the challenges that we actually face even in cloud, and how we can solve it, or what are things you can use it. And also, like I would like to make this like as discussive as possible. So feel free to chime in, share some of your insights. Maybe you have encountered similar problems and such. So let's just share insights and just make it a group discussion rather than just me presenting. I would really love that. So see, I'll give a good intro about myself, but I'll just briefly introduce myself. So I'm currently a cloud engineer working at Google, working with Google's clients as well as some internal products and such. Previously, I did cloud security as an architect and engineer for of a global private equity firm, Blackstone, based in New York. Along with that, I also have like multiple IT certifications, so AWS, Google, Oracle, Docker, all of that. So I have been in IT space for over like 7 years now. So I've been doing like all over from like coding as in software development from Java, JavaScript, Python, all the way to cloud and Docker and orchestration, along with like providing consulting services across. I also train people on cloud. So I'm a Google Cloud authorized trainer, conducting training sessions and helping them achieve certifications or just give them more comprehensive understanding of cloud as well. In terms of AWS, I also help like AWS to create the questions for the exams, like their exam process and such, as a subject matter expert. So I do some of the contributions, and I also like as a just like here, I also like speak at podcasts and be a host at meetups and such. So thank you, CL, for inviting me here and allow me to share some of my insights with everyone here. So just a quick disclaimer, everything presented is for general information purpose only, doesn't express opinions or doesn't do any endorsement for any products or doesn't tie to my employer. These are all personally my views. So I would refrain from anyone that saying that this ties to Google or any of my employers. Is strictly my personal opinions and views here. Right. So when we talk about cloud overall, right? So there is like people understand that everyone is moving to cloud, and whenever we talk that okay, why not just move something to cloud, or cloud do something in Kubernetes and it solves all the infra problem, but that's not usually the case, right? So I wanted to start with creating that basic just understanding what actually cloud is and what are some types that are being used. So cloud is basically generating on-demand computing resources, everything from your applications to your data centers over the internet. So you still need internet, you still need some kind of connectivity to be able to connect to your resources. That does not just go away. But it's just like when there's someone say that someone else's computer, also that is not entirely right. It's not just computer, but it's like someone else's ecosystem in general. And briefly, like we can classify cloud into three things: SaaS is software as a service, platform as a service, and infra as a service. So you might be aware of software as a service that we use just that you download locally on your machine, like your Microsoft Office or the Zoom that we downloaded just using it as software. And then you have the platform where someone allows you to develop something on top of it that you can create. So something like your Dropbox.com or Microsoft Office Online and such. And at end comes the infra as a service, which is actually creating your compute resources, database storage, which some of you might be working within IT like all these years, actually creating and maintaining those infrastructure resources, but in cloud for it. We can classify them, or if you just want to compare these models. So when you are on premises or what might be doing legacy traditionally, you would be maintaining all of these starting from your applications, data, your runtime, to your servers, and even networking, all by yourself. on physical networks where you would actually go into your data center and you would configure some wires and configure networks. You will configure storage. All that you will be responsible for all of that. But when you move to cloud or one of the as a service platform, the provider from where you're getting that service shares that responsibility. So they manage some of that. When we go to infrastructure like you still manage your applications, data, and runtime, and your operating system. You have to do your own patching and own your vulnerability management, making sure everything is up to date. But your actually server, storage, networking, all the physical part that's involved, that's all taken care of by your provider there. Platform as a service, it increases the management by someone else. So in that, your the management of OS or runtime or even your language packages, that all is taken care of by the provider. And when you move to completely software as a service, everything else is being managed by others in there or other individuals. So if you're using one of the public cloud providers, might be like Google or Amazon or Oracle, they would be taking care of all of these platform that other manages for you. Any questions here, anyone? I got another example, which all of you might be able to relate. Just to tie that back in about your as a service, you take pizza as a service. Like everyone likes pizza, everyone eats pizza. So we can have like, if we compare our as a service model to the pizza player, it's like your traditional can be compared to what you make at home. You start from scratch, like having your own dough and kneading it, creating the toppings and using your own oven and fire and even your table and drinks for it. But when you go to something like Costco or Sam's Club or one of the warehouse and just get the frozen pizza, which is like take and bake, you don't have to worry about the some of these bottom part here, like your dough or toppings or cheese. That's given for you. The product is done. Now you just manage it. You manage it. You cook it however you like. You heat it in your there's the wood oven or it's your stone oven or even just a regular microwave oven or even like toaster oven. So it's up to you what you do. That's your IAS. And then a past service or the platform as a service becomes where you get the pizza delivered and you're only responsible for your drinks and your own table in your own home, pretty much, or wherever you like in the park, you get the park bench. So you're only responsible for that. But software as a service, you just go out and eat. That's it. You don't have to worry about anything. Not even bringing your own table, no drinks, nothing. It's all taken care of by someone else. Well, one thing common in all these four is you are the one paying money eventually. So that does not change. You still pay the bill, all of that. However, the bill reduces over time. So that's the advantage of cloud. When you say like elasticity and scalability, that's what it reduces there. So that was some of the basics we learned on cloud. But today we'll focus a lot of our like discussion and talk on the infrastructure as a service feature. So for IaaS, what we saw that it's pay as you go, because I said you're still paying money, but you pay over time. If you were to earn traditional or you're making at home, you'll pay for all the ingredients, all of your oven or table, all of that upfront. You'll have to have all that money, and only then you can get all these ingredients and equipments. But for IaaS, it's like you pay as you go. So you only pay for whatever things you get for it. For example, you are getting here like pizza dough, tomato sauce, and toppings from the provider. But then on that, you only pay for whatever drinks you get. And if you want drinks, that's optional. Same way with fire and oven, you can choose whatever oven you want, and you only pay for whenever you use it. So if you use it just once to bake your pizza, you only pay for that once, but you don't have to have that big investment on it. So it's pay as you go model. You get the agility and scalability. So if you want to bake like 100 pizzas or 50 pizzas or just like one pizza for yourself, you only pay for that, and you can easily rely on someone else to bake it for you once you pay for it. And just because you can easily scale it, you can also optimize the cost. Like you can get bulk discounts. Let's say instead of like one pizza, you are baking like five pizzas together. You can save some time and also effort because you're baking five at a time. So that way you're optimizing similarly your cost and your usage for that. Some very familiar names and logos here for IaaS, the AWS, Google, Azure, and Oracle. And I did include IBM Cloud here because I know they do have a cloud presence. And even though it's not as mature, personally, that I think it's not as mature, but I thought it should be good to include here as well. Any questions or anyone has like still vague understanding of what cloud is, or does this make sense? What is all cloud about?
I have a question though, what you said about IBM though. Are we talking about, did IBM have a cloud service before they bought Red Hat? Because now it's Red Hat, and I don't know, is it the same maturity? Because
No, it's not. First off, IBM had a cloud position, and they had it for probably at least 10 years. And so when you talk about this, it's most of the time the leader is Watson, IA work, but other things that are, other positions on cloud are better, like AWS or Google, because they're better stable than IBM's cloud. But yes, it still works. And so when you think about what Red Hat is doing, Red Hat is like giving private cloud with OpenShift, and that's not here. And so, but you're creating it as a cloud system.
So you're saying that the Red Hat with OpenShift is not mature enough really to compete maybe with its larger.
No, it's better. OpenShift is better because you could put it on AWS or Google or IBM or Oracle's.
No, I was thinking in terms of IBM from a financial position. It seems to be relying on their cloud. They want to have a cloud and everybody pay them rent, and that's how they're going to make their money. So that's what I was curious about. So it sounds like their products, Red Hat products, are still a good thing or a potential flow of income, but they're perpetual stream, just as Durban explained about the different versions of cloud. You're going to pay a price to make your pizza. It just depends how who's making the pizza, and that's okay. It makes sense. Thanks very much, Peter.
It's the ingredients.
Right.
That's what you're talking about this.
I agree. Yeah, I understand. Thank you.
Yeah, so definitely agree with Peter. Like Watson, so in fact, my first exposure to, if I would say, to something like cloud was when I made one of the apps using like IBM's Watson, one of the hackathons. That's when I learned, like, true sense, we could call it as a cloud, because Watson was doing that AI features and talking about that when it was hosted somewhere else. And then, and for me, my next exposure was to AWS after that, pretty much. So yeah, we can classify that as like one of the early cloud as well. And then Oracle has been one of the recent players, but also been gaining a lot of traction. So something like Zoom is using Oracle for a lot of the infrastructure needs right now. So yeah, the more players are coming to the market than just like the top ones that we know, who were like first to the market and how that dominance. So let's take cloud security. Like, we learned about cloud, but then what exactly is security and how can we help secure that cloud? So when we talk about security in terms of it's policies, technologies, applications, all of the people, process, culture part that applies to traditional security, whether it's InfoSec or ITSec, that still applies. But in terms of cloud, that all now applies to virtualized IP, virtualized data or applications, because it's not physical, that you cannot see or touch. So all that same policies and set apply, but all to virtualized data and virtualized infrastructure now. It's still a part of the network security and broadly information security. So cloud still falls under IT. So all of those policies and rules still apply, and responsibilities also apply. However, one thing that changes here compared to traditional IT or on-premises, it becomes a joint responsibility. Because since someone else is now managing some portion of your IT stack, they are also responsible for some sort of security for things that they manage for it. So if you were to see that joint responsibility or shared security model for some of the cloud providers out there, so I put this like for AWS and GCP here. If you were to use the AWS, then AWS says that they are responsible for security of the cloud because they are providing that service like as a service portion. So everything below, that's their responsibility. So managing your regions and availability zones or edge locations, which are pretty much the data centers themselves located in those geographical locations. So they are responsible for maintaining them and managing it. They need to manage their connectivity and network or any storage equipment. So whatever physical maintenance that you might be doing, they still need, now that all that needs to be done by AWS for it. But what you need to do is a security of responsibility in the cloud. So whatever you pull on top of that, so whenever you get a pizza, So whatever toppings you put on top of it, you need to decide what toppings you want and what you don't want on it. And since you put the toppings, like you need to make sure you adhere to everyone else's taste in the family, or you might disappoint someone in there. So that way, you're responsible for things like your customers' data on it because you are putting that on cloud. It's you as a provider or you as a IT operator deciding to put that data on the cloud. So you are responsible for your data. Responsible for the application and IAM. So IAM here is highlighted and specifically said because, as someone mentioned earlier, like we need to talk about least privilege. It's up to us as users that how do we least privilege and make sure only right people has access to certain data or certain resources for it. So that's highlighted here. But then also operating systems, network, and firewalls. So we got all the ingredients, we got all the tools, services that they provide, but now we need to put them together. That how do we put them together? Do we put like uh, tomato sauce first on the pizza, or do we put like the garlic topping first? Like we want the garlic in the base. It's up to us. So we need to decide how do we operate it. And same goes with like security on data side, like encryption or protection on there that we do. So all the integrity, encryption, identity, or file system, all of that protection still falls on the user's part. So as users or customers, that's our job to do it for it. So that's how you can distinguish that joint responsibility specifically. And if we go back to the IaaS, PaaS, and SaaS model that we discussed earlier, this responsibility also varies. The line between the responsibility of the cloud and in the cloud changes based on what as a service model you are using. So, for example, if you are using the IaaS, where you're just using the infrastructure as a service, you're responsible for a lot of things: your operating system, your access authentication, all the operations, maintaining, patching, identity, that who can log into your instance, SSH access or RDP. All of that is your responsibility when you use the infrastructure as service for that. But when you use the PaaS, so platform as a service, where we use a App Engine and GCP or Elastic Beanstalk in AWS or anything. So in that OS and all that, we never have access to operating system. You do not have to worry about identity, that who is logging into it, because it's all done by someone else, the provider for you. So responsibility decreases there. And when you use something like software as a service, where you do like Gmail or Drive or any of the online web platforms, you need to worry about the content that you put in there and your access policies. Whom are you sharing that with? Are you sharing responsibly, or are you consuming yourself? So that would be the difference that when you get in the SaaS platform. Rest all is taken care of by a provider. When you use
Just one
gmail.com,
moment. Just one moment. When you're talking about identity as a platform as a service, it's kind of blurred because of things like OAuth and OpenID. And because of these issues, you are now even more in need of special control and understanding that that's more of your responsibilities as a developer or an administrator or a user of cloud resources. And therefore, they're not really the responsibility of the provider. And therefore, you are taking on much more risk than what is really being touted by any of the cloud providers. And therefore, the cloud providers themselves, by giving so much flexibility, especially for the second point that you have there, for access policies are the weakest link, the largest, weakest link that no one really understands. And that is the biggest thing that I would want you to talk about this today.
sure. Yeah, you hit the right spot. Access policies is in fact hard, and that's like equivalent to, like, you can say P equals NP problem in computer science. But yes, that is hard, and that's why, even though regardless of the platform or service you use, it's on us as users to manage that. So I think I do have a couple of slides or a couple of things that we can talk about in access policies, how to improve it, like recommendations, using the recommendation engine and all that stuff. So we'll cover like slightly on that for sure. But yeah, we can like discuss it more freely and such right after during the session. Yeah, feel free to like interrupt and anyone like share your insights and thoughts. Right. Any other questions or comments here?
I have a question though. When I'm looking at AWS and you look at the operating system and you're in the blue section, well, when you create an environment in AWS, you're using, their setup, their code, okay, at the lack of anything. So if you set up SQL database or something and it gets sick based, other than development reasons, it starts misbehaving, do you talk to Microsoft? Do we talk to him? Because I'm talking more in an application level versus a code level.
Mhm.
How does
So,
that work based on where you have it placed?
Sure. So if you install it yourself, right, you put on a operating system. So you spin up an EC2 instance, that's an AWS, and on that of that you install MySQL. So AWS responsibility ends when they give you operating system. So you launched an instance and you install MySQL. So that's fine. But if any new vulnerability comes and issues come on it, this is discovered in the SQL that gets sick, then it's up to us as users to actually go make sure it's patched. It's not AWS responsibility there, and that's why operating system is in the user part here, operating system. But
Okay.
here, the OS is again like green because that's the PaaS, platform as a service. So AWS has Beanstalk or something like a Lambda for serverless, or in PaaS, Google has App Engine. So there, you don't even get access to OS. You don't get to choose specifically what OS you decide or what flavor you want to choose for it. You just give them the application and your actual app level code, and they decide for you what OS you want to pick, and then what SQL, like you want a high availability, failover, all that. So all that operating system access is to the provider themselves in that part. So
But
that's
here's
why
another
it's
thought,
like
real
different.
quick. Here's another thought. When you order your OS, you still have the ability to configure your OS
Right.
for whatever you want. And I want to bring you back to a problem like IBM created. AIX was a big problem because it was created like saving power at one point. And therefore, when they created AIX, it would stop CPUs that were not being used. And if you didn't understand the configuration that you were trying to get 100% of the computer, then you didn't change the configuration that was by default. Therefore, it wouldn't give you 100% of the CPUs running. And so you, again, it's your responsibility for the configuration of the OS. If it's a supported OS for the server or the software that you installed it, like SQL, Microsoft SQL Server, then therefore it's not the supplier of the OS, it's not the supplier of the software. You have to look, did you change the configuration of the OS? Is the OS updated? Is it supported? Therefore, look at yourself personally. Look at yourself personally.
Yep, a good point. And like somehow, like also there is also a bit of people that are scared that once they move to cloud, the DB administrators and all that, they're like, oh, it might take away our jobs because now it's all in cloud. But that's just wrong, because you still need those DB admins. You still need those operators to configure and operate it correctly for it. So moving to cloud doesn't necessarily like decrease your manpower, or you cannot just get rid of your resources that way. In fact, as Peter mentioned, you might even need more help there to configure the right settings and right configurations for it. Good comments, everyone. Anything else anyone wants to add? Let's move on to the next one. So now we see like how the security in cloud is different than what you would do legacy like on premises. So obviously, first one is the data centers. First, you were used to in-house data centers. If something, let's say, you get under attack or anything, you can literally just like plug out your internet connection. You can go and pull out your wires in the data centers or your server racks. But now it's all third-party data centers. You do not have control over it. You don't have control over it, that who's managing what. You do have software defined network and software defined control, but not. So that's what it's different now compared to your like on premises one. The cost is again a factor when you are investing in some resources. Let's say either it's CrowdStrike or Palo Alto firewalls and all that physical. That all, if you're on premises, you'll be paying upfront for it. That you are buying for certain years and just having it installed. You'll put like a NIC or some kind of a switch in your data center. But now, when you're in cloud, you don't need to do any of that. You don't have to actually have to invest upfront in all of that, and you can do pay as you go model, or you can also just have special different kind of contracts when you are using the cloud product. Scaling is other big thing. So let's say if you or one of your apps or someone just put it on Reddit and becomes viral overnight, then you might have difficulty like scaling it. If you're just on premise, you might run out of storage. You are limited by the capacity. But in cloud, all you have to do is just like pay them more money, or just do like upfront increase your auto scaling or load balancing capabilities, and it can all be done within matter of minutes at times. It's quickly scalable. And similarly for security tools, you want to increase your WAF from like one instance or one singular instance of WAF in front of your one data center or server. You can replicate and do like failovers and high availability in cloud. So in security also that scales. The efficiency, you can only pay for what you use, and you can actually increase your efficiency fully. So Peter mentioned about the IBM part earlier. So in cloud, you can actually make sure you have full understanding of how much you are using and what you're allowed to use for it. Time to market, because of you can do all of these things faster, that gets reduced in cloud. And also usage based cost, again, because all of the, let's say, IT companies or even your departments in finance and everyone, the major thing is cost. Everyone likes to see less cost, honestly. So that's how you can compare the traditional security versus the security in cloud, pretty much. So anyone who's just getting started and trying to like convince the leadership to go to cloud or just trying to explore, these are some of the good points that you can bring up or discuss. And another thing, when you are developing or moving in cloud, your as you increase your innovation or do more cloud adoption, security automatically increases in the sense, because if you are using the efficient cloud products, let's say you're moving from IaaS to PaaS or from PaaS to eventually SaaS at one point, then your security automatically increases because some of those are built into it. So let's say if we go back to this model, when we go from SaaS, like you're just using compute engine or storage, but when you use some more advanced cloud native technologies and services like BigQuery or App Engine here, the security automatically increases because it's built in there. You don't have to worry about it. And so generally what you would have traditionally, that you might move on, create a new technology first or a new application, and then worry about security. So that does not happen, or that's not the case when you're actually adopting more to cloud or developing cloud native services there. Anyone, any points to share here or want to?
My point is, you can't pay enough money. There is no basis of real cost for security. If you think about the latest breaches in security that have been so public, if they knew that they could pay more money, they would have paid for it. But it was really the loss of control, the loss of IT controls inside of the company to control delivery of software, to control traditional user IDs and passwords, traditional bill of materials for what you deliver as software. And therefore, when you go to the cloud, if you don't understand every toggle, switch, button, everything inside of it, you are at risk. And most of the CEOs of today don't think like, have I been breached? How much is it going to cost me? Because I know I've been breached. I just don't know where it is.
There it is. Yep. Good point there. And also when CISOs think about it, they're like, okay, so what kind of, they are aware of whether it's like, they want to know what can cause like reputational risk or financial risk or other areas, but they need to know like what are the points and what are the gaps that they can fill in. And for that, number one thing they need is the education, or users who are like knowledgeable in cloud know what they are doing. And one thing to manage a lot of companies rely on for that is like certifications and making sure users know what they are doing for it. And that also like results in increased demand for security and cloud security folks for it.
I got a question though regarding like solar winds and downloading their big problem. But then all it makes me do is look at GitHub. Now I have a cloud-based repository of code. How do we learn anything from in securing that code from the whole solar winds example? Yes. Granted, there apparently was an individual developer, but I'm just like, when stuff is being sucked off the cloud as, oh, that's acceptable, is there, and especially from a guy who's aware of security, I'm just kind of curious, am I off base or is that, realistic?
So I would say you are realistic, and that's when like a lot of companies have, when you download those code from GitHub, or you just like look and try to download those open source codes. That's why it's important to have these standards for open source use at your company. So we have the like we say that okay, FOSS is good, free and open source software. That's good. That gain a lot of credibility. But also before you try to implement in your own company or try to download the code, you need to make sure you go through like particular like scanning of code, whether it's like static, dynamic, all that. Which again, SolarWinds thing that happened would have still resulted into malicious code downloaded per se. But still, those are some steps that we can take for it. So downloading any of the open source code from GitHub, GitLab, all of that, it's still a risk. And that's why we need to maintain specific standards and govern against it and have your governance and risk matrix developed such that you allow only certain blocks of code or certain code libraries to be used within your applications, I would say.
Well, think about this again. They lost control of the delivery of their software. And it wasn't coming from public source. It was inside their own company where someone was able to insert something and they lost the visibility of the bill of materials that were being delivered to their own security product. If anything, everybody should require a bill of materials certification for every component that has been like a SHA-256 on it, and that there is a test on it that you have traceability like an aircraft part. And therefore, if you're a security company, you should have the highest visibility for traceability of your solution going out to the public.
Yep, definitely. So moving on, like security, we see the difference, but then also another part is that resolving perimeters. Like first, we're just limited on your data center. All your data and server would rely on just one room. You would control access yourself, who can get in and get out. And similarly, when you had users connecting to your applications, you know for sure that they have your mobile device or your laptop. Only way they can come and connect to the network is the VPN. There is nothing else outside of that room that can actually come in without your permission, and like that. So, but now with moving to cloud, your perimeter also significantly increases. What are things you protect and you prevent any attacks or anything. With cloud, like anyone can connect to any computer or server when using some of the SaaS tools like Gmail or even like platform and SolarWinds is example that everyone is used to using and such. So again, now all that are becoming part of your data center or your ecosystem, and need to worry about connections from all of that. There's no set perimeter anymore, right? So that also increases, like even though cloud like makes it easy for applications developers and all that, but as a security folks, it does increase our challenge and our perimeter that we need to worry about in that sense. So it increases our ecosystem. And now when you install any agent, let's say if you're on-prem, you do SolarWinds or have your firewall set up and things. But when other devices or someone else, the provider is coming in, you also need to worry about what are they storing in. And regulators and auditors are looking at that, at what platform you are using and how is their security being maintained for it. So you need to worry about them as well. So that's how this security becomes different in cloud. Anyone have any comments or thoughts here? So another thing, since we cannot do anything physically, or we don't have any access to it, everything is now in like software. You can configure everything just by going to a screen, logging into it. And all the infrastructure part that you must be doing, whether it's like networking, authentication, or authorization, or tying back to IAM, all your data and security, all of that can be managed separately now by separate entities. But also since you don't have it physical, it makes it like a bit more challenging for it. And one thing to make it easy is like because it's in software, there's also APIs ordered for everything. So as IT operators or as like administrators, you might not be used to like let's say coding, and we might be familiar with like API languages and syntax to use and such, because we might only be using commands on Switch. Because when let's say when I use Cisco's and Meraki's and that time, like you would just go to the Switch, like log into it and just execute some commands for it. I never had to use the API. I could just get without using it. But now since everything is dynamic and scalable and just away from me, I need to rely on that API use as well, such that I can automate things easily for it. And that's why this API, like it's also important for these operators and all of like IT folks to learn some aspect of coding or scripting so that we can leverage these technologies like more easily and efficiently. So since we can cover all of these are separate, I will just like do a walkthrough of like how you can do like defense in depth pretty much, or what are the services that cloud brings us to the table in terms of security for us. So if we were to begin with like networking, so if we see this networking itself, in terms of Google Cloud here, I just have example of Google here. Just a second, someone put something in chat here. Let me see. But yeah, in terms of like Google here, you can pretty much compare or put security at each level of your network. So whether it's someone coming from outside your external user, then you have the load balancers, your identity aware proxy, or your cloud armor for security and encryption, like TLS and such, which you would do on premises as well. You rely on like those F5 load balancers and such. But then a lot of things you can also control behind the scenes. Once the network or once the user is inside your network, you can control what they can do, and it's because they have more flexibility. It's important that we learn all the configurations or what all needs to be done for it. And we have several options. You can use something like VPC service controls to determine like who can go and where. So if we have like one rack of server and we have another rack in the same data center, we can specifically control that who can connect from that one data center or one rack to other rack. We can control the firewall level, the proxies, or even like VPNs and such. So all of the granularity is available in cloud. So even though it's challenging, and we see all these challenges coming up with cloud, on but flexibility, we also get that added control, which we do not get traditionally on premises for all of the apps. So whether you want to connect like private connections, or you want to make sure you only do specific NATs or proxies, all that is available. And if you want to go one level below of it, even on an application level or your infrastructure level, that's when you can also use something like IAM or some service mesh if you're using Istio, Kubernetes, or containers for it. You can create service accounts so your servers can connect and talk to each other for automation, and you can have separate policies here. So when we talk about IAM and least privileging, I personally see it as just like one aspect of overall security in a cloud. Even though it's one aspect, it's a big layer, and it's like it can get pretty complex. But IAM should always, it's like one layer of security, I would say, for any resource that you create. There's a lot of things you can also configure or some security wise on the resource itself. So that helps you do it better in that case. And talking about IAM, I want to like also just highlight that what exactly IAM is and how does that IAM differ in cloud compared to on-premises. And so again, I have examples of like two providers here, AWS and Google Cloud. So most of you are familiar with like AWS or starting to use that. In AWS IAM, they separate these out as identities and permissions. So if you are using your Active Directory on premises or for authentication, and then in that we have the security groups where we say who has access to what groups and what they can access, what server or what credential, where they use their SSO login or they use their Microsoft AD login for it. And then we might also separate it out into like, privileged accounts, and you have to use the your admin credential for certain servers. uh, Similar thing translates here to cloud as well. So when we do IAM and we have separate identities and where we can maintain that who is controlling or who is trying to request access for certain things, whether it's users or a group of users or just specific roles for that. That someone is assuming someone else's identity and trying to get in and access it. So that is managed separately versus the permissions that what permissions can they connect to, or like what are the resources available for them. And again, all of these is like codable, so you can automate that. And it's also common scripting languages like your even your JSON or YAML, Python, all of that works. For Microsoft AD, you might be using the PowerShell scripts to do some of those Active Directory actions and functions. So similarly, in here we can use JSON or CloudFormation templates within AWS or any kind of scripting familiar with. But since these are managed separately, and you can actually have like a separation of duties even in your resources, like going back to people, process, and culture part, that you can separate these out, that who is allowed to create new users and who is allowed to give them permissions specifically. And you can do this time based, only like one person, like we can have limited time within minutes, within seconds, or even like hours and days that you get the access for set amount of time. And since all of this is like hierarchical, whether you use Google, AWS, or any platform, you can also do some of these same permissions at the top level or higher level than the users themselves for it. And since you can do it higher level and multiple levels, you can also go as granular as you like. For example, if you're using the storage, you can say like who is the admin of the storage and who is the viewer or who is the creator for that. You can separate that duties and identities completely for it. So you get that lot of like flexibility and granularity. And that's why you, as I think Peter mentioned earlier, you don't just like get it or because they are doing it or something like operating system provider is doing it, you it's not that you get rid of your responsibilities. In fact, you need to pay more attention than what you do because that flexibility and granularity comes into play.
So let me stop you right here because you're on the perfect slide that I want to talk about just for 1 second.
Sure.
So when you think about creating a user and you give them an IAM policy that, hey, I want to give you write permission to my S3 bucket. I'm on, compute on AWS. Okay, so I'm just going to give the AWS compute, I'm going to give them write permissions. That's all it is. It's a checkbox. But all of a sudden, if you hang on that for a second, all of a sudden a number pops up and says there's 200 plus policies, 200 plus policies on a write permission to an S3 bucket? You gotta be kidding me. So if you don't understand all 200 plus of those things, go in there, click write, and uncheck everything, and only take what is bare bones absolutely necessary. Because I'll tell you, when you get inside of there, your user of that compute can change its role to become an inherited role onto your VCP and therefore write something out to public from the CPU that is reading your S3 bucket.
Yep, exactly. So all these providers does give you the flexibility to like create your own roles and pick your own. But I would be honest, I would say like for any new user or novice, they don't make it easy for it in that sense. They don't make it easy for them to pick up the specific permissions and not choose that. You need to know how to create those custom roles and custom permissions for it.
I have a quick question. Are you going to talk about or explain like the relationship between roles and permissions?
I did not have that planned, but we can go through that if you want to understand that more in detail. I don't have any slides for that setup, but we can talk through it if you want.
Yeah. So, I mean, they're not really, are they independent of each other, or is it like, does it work where you assign permissions to roles at some point, or you see what I'm trying to ask?
Yes. So they're independent, but also tied together, as you said. So you can configure them independently, but they are tied to it. So if you take example of AWS, in AWS, if you go to IAM console, in that you will see different things. You'll see like roles and then policies, and then you'll say groups and users. So in that roles, you create the roles that what you want for it. You just name them and create roles, but then you attach policies to them that what policies you want to allow to be created. So in roles can be like three different kinds. Technically, it can be like predefined. So AWS or Google makes it easier for you in terms of if your database administrator, DB admin, you would need these sets of permissions ideally. So they create a curated role for you already that you can use, which has pre-attached policies and permissions with it. But then other one is the custom roles where you can pick your own policies and your permissions. So you can still have separate permissions created attached to a single policy, and then you can attach that policy to a role in it whenever you like. You can have it like time-based automation. For example, as a user, like as Darpan, I need access to some kind of admin management for compute instances or EC2. Then I can go to a specific, let's say, fill up a form. I have a middle interface. In that, I can say I want this access for 10 minutes. And then I can have automation set up such that those specific policies and permissions get attached to my role that I'm assuming temporarily. And then once I'm done with my work, those permissions get detached. So you can have that maintain them as separately with each other. So there's no like one-to-one relationship.
Got it. So is it safe to say that policies are like a subset of permissions, or you could attach multiple policies to a permissions, or is that the wrong?
I would say their permission and policies are like one thing. So policy comprises of permissions.
I see.
Think about a resource for a moment. When you have resources, policies work on resources. Think of like them as pinholes in permissions to allow you to pass between different resources, like an S3 bucket or a CPU, the fact that you're connecting to these things. And these are the policies that allow you to go back and forth to these things with different types of capabilities. Think about network access or the fact that you can broaden something. But when you see what is on the systems for AWS, certain things like, an EC2 instance, when you look at these things, they have way too much capability. And because other companies need these capabilities in policies, that's why they exist, okay? But you need to be very careful when looking, especially at policies, because when you automate something, if you only automate something to like the right policy on an EC2 instance and you just give blanket right to it, and you didn't see the 200 plus policies underneath it, you're in danger territory, as an example. This is one of the biggest things that I have seen companies fail the most at, because this is the way they get their data like encrypted and held hostage, and oh my God. So this is the reason why I'm talking about this.
Yep. And providers also do realize that one thing might not fit everyone. So what Google has started doing recently is Google actually provides you with recommendations. So once you create those roles and you just start using it, they will analyze your usage for like 30 days. And after that, provide you recommendations that what all permissions you should remove from that role that the user is not using it. So even if you create a predefined role and assign that to user, they will analyze that, okay, is this user using this storage.object admin, or is he using object creator? Is like using too many, actually creating the buckets or objects, or is he just viewing them? Is he going to delete them? So they analyze it based on machine learning, and then they give you a recommendation that you should remove these permissions from this role, from this user. And also says that this user, because he's doing these permissions, like he's creating a new database schema and all that, then he might need these additional permissions. It also does recommend that. That's the policy intelligence part that Google Cloud is doing that you can use.
Most of these systems also have, as what is on the side of this slide right now in front of you, is a policies that are inherited, okay? And when you inherit something, you inherit good as well as you inherit bad. Buyer beware. Because in the policy section, most of the people who talk about identities and permissions, most times do not talk about how policies are affecting these things and how policies can expand what you consider your permissions to be. And that's why when we talk about this, that's the EC2 bucket is the easiest thing to talk about when you look inside the policies of this thing, because it's a glaring huge flexibility that most companies don't really pay attention to.
Mm-hmm. Yep, definitely. And then and especially if someone's just starting out or just exploring, they might not. The thing is, they might not even know that you can do this, and that's why just let it go through for it. Does it answer, like, JP, your question and everyone else's comments?
It does. I appreciate that.
Cool. So if we move on, right? So here is something that Oracle puts out, that you can have the security controls for the cloud, also what Oracle does on their side, but what users can do on it, or what capabilities do they provide for everyone. And this data center model or access control model really like translates to pretty much all the cloud providers and all the managed providers for it. I decided to include this slide and this graphic here. I thought just address somewhat more granularity and some terms that all of you might be familiar with here. So whether you're looking for your TLS for HTTP or IP address filtering, IPsec, VPNs, all of that capability is available in cloud, which you have the customization capability, as well as you can use the predefined settings for that. Similarly, when we say that managed provider, managed service, even they have these set of like rules and policies for their staff and on their side that they manage and put it out. So encrypting everything or putting firewalls, making sure there's two-factor authentication in place for everything, that all of their users and all of their users' usage also gets audited, and making sure all these systems that are managed, they're being patched at regular intervals or getting those reviews being done for access and all that. Similarly, for their physical staff or someone like what you might have in your data center, they also have similar resources. In fact, like some added security on their data centers. Which, as in, if they're a small or a medium business, you might not be able to, let's say, afford all of these capabilities just for your data in your personal data center. And that's when when you go to the provider, you get their added capability on provider side as well that they do, because they're doing it for multiple customers at large scale, becomes obviously cost effective for them to do all of that. Also, the separation of duties, just like how it's a customer responsibility to do that on user side or on top of the infrastructure, also on their side, my providers also do all of these same policies like separation of duties, making sure all the logs are going to SIEM or managing their content and identity, all of that.
But think about this. How often do companies really audit this stuff? Just even look at it. I don't even care if you get 3 people in a room and talk about controls. After you put this thing up, hey, it's done. It's out there. Other than like doing fixes on the software or we need a new feature, most of the companies don't look at this stuff. They don't care about the users. They don't care about the permissions. God forbid we look at the policies. My God, think about this. Oracle got it right when they were creating some of the software about separation of duties when they created like audit systems for database systems. Like either you fence it up like database vault or audit vault inside of an Oracle database system. They made it so that HR could like shut somebody down for looking at data on the wrong system. Okay, that was great. But now when you go into the cloud, now everybody has the ability to create their own configuration. Most of the people don't have a consensus group to sit down and talk about these things and talk about theft, loss, experiences of pain, to say, I need everybody who had the biggest pain in their IT career and stick them in the room and say, we need to review the audit controls.
Yep.
You're smiling. I hope you're really snickering when I'm talking about this stuff.
Yeah. I mean, even in my experience, like I would say some of my previous companies and employers, even as you mentioned, getting people in the room and actually acting on these policies is also hard. Even if you set up those policies and our reviews, taking action on it takes forever. Right. So definitely
Most of the time when I came in, the theft had already came in and I had to figure out how to fence it off so that you could not steal $10 million from the auditor's bank account.
Yeah. Anyone else, any thoughts or comments on it before moving on? So next time to focus on like some of these controls, like different controls we can actually put in place. So we saw these security controls that provider puts in place and they have it on their part and something that we can customize. What would you classify, and just like I would leave you with like top 4 categories of controls we can do is like, or with some of which you should actually like implement when going to cloud. Start with deterrent, right? So when you associate into a new system, log into let's say your corporate computer, you get a warning that everything you gets do on this gets recorded. You'll be prosecuted if you do something malicious and such. So sometimes even those foundational or like warning signs do prevent users, at least giving them information that what can happen if you do. Similarly, putting like two-factor authentication. Someone who's just trying to log in by guessing your password and getting into the systems. If you are 2FA, even if they have like they would take a step back and think about, okay, that should I actually go all and make all the effort to break this 2FA as well and such. So sometimes those actions and those policies you put in place also acts as a deterrent to attack or to any malicious activity. Right? So I recommend putting some deterrent controls on any of your IT systems, even like personally, making sure everything has 2FA and you make sure like using different passwords. So all the basic IT policies that apply to it. And then comes like preventive controls. And I have like IAM here as a strong IAM, also bolded, because IAM, though not comprehensive for all security, it is fundamental for it. You need to make sure you get the IAM right, first of all. Because if you have the IAM right, then all of that, all of the other ones, you can probably put as a secondary. But IAM is important here again. I'll put the MFA again here for
Example that I can
preventive.
give you. Here's a ridiculous example that I can give you. A large company of 150,000 employees, 150,000 employees, has a system out there where they expose the IAM system's admin password inside of the system as a flat password. And I'm not kidding you. And therefore, when I think about this company, I don't want to have any of my money in their system at all.
Exactly. I wouldn't want that either. Did you like point it out to them, like right to their CISO or something like that? Point it out?
I told senior management on a meeting with 220 people, senior manager, vice presidents, and I told them that you have an open password for the admin, for the IAM system, the LDAP system inside of your own servers. And therefore you're running this system and you want to also sell this to the public? Are you insane?
Did you get a positive response from them?
Yes, I got a response. I got riffed. This is why I'm publicly available. Someone wants to hire me, please talk to me. Java, JavaScript, Oracle, IBM, containerization, Kafka, OpenShift, whatever everybody needs.
Cool. Yeah, I mean that you're right. It's ridiculous to have that. I don't know what to say, to be honest. There, like, yeah, it's sadly like there are like companies and corporations like that. I remember I pointed like something similar to one of the companies like 2 years ago. But they were quite receptive of it and they were like appreciative. And in fact, they sent me a follow up like after like 3 days that, hey, we are trying to fix it. Thanks for pointing it out and such. So there are companies also appreciative for it. So I'll say continue to do that, continue finding it out, any anomalies and such, and report it. But yeah, moving on. So besides like IAM, making sure you use like MFA and have the guardrails in place. So even if like let's say someone gets into your system, you can prevent the escalation and making them prevent them from moving around, like house guardrails in place, have separation of duties, have firewalls, encryption, uh, availability. All of those, as you can still prevent some attacks. So if you were to under like DDoS, if you had like high availability configured and you had like your load balancing, all that in place, which you can get on cloud easily, you might be able to withstand that DDoS attack as well of some smaller of some capacity in there. And since you are using those services from cloud provider, you can also engage them and their services to help you out in such scenarios. But then you did deterrent, you did preventive. But then what if someone was still able to get into it? Like they were able to go through IAM credentials, pass through MFA. What if they are in? It's important to have those detective controls to be able to detect when someone is in there already. And some ways you can do is like logging, monitoring, seeing for anomalies, or even drift detection. Something changes abnormal in it. So what we happen with like solar winds and such, if something like that happens, someone is in your system, you want to be able to detect them easily. Even if let's say now the solar winds thing came out, you want to make sure that nothing they did not get into your system. Even in order to do that, you need to make sure you have these peripheral or ancillary infrastructure in place already for it. So that's why these detective controls are important, even though you're confident of your preventive and deterrent controls for it. You need to have it in place. And once they're in, you find there's someone else in it, they're trying to make some changes. Then what you do, you try to correct it, any changes. You try to like catch them or undo the any actions that they did. For that, you need to have those corrective controls that what are some of the baseline configurations. And then you can have the monitoring on those configurations that everything should be from this base and not like move away, should not be changed from this. So have those baseline configurations, have those response and remediation strategies and playbooks in place, have appropriate notifications. Sometimes we get a lot of alerts and we might get that what is it, alert fatigue, but then that's also important to tune that signal to noise ratio, that how much is the noise and what's the actual alert that you need to pay attention to for it. And report all of this to your leadership or CISO if you're on the C-suite, report it to your board at times that we did all of these and activities. So when you move to cloud, you can actually use some of these controls to your advantage for it. And CrowdStrike or Okta or SSO solutions and endpoint solutions, all of these would fit in these controls. Like you can do prevention, you can do detection, and you can also use some of the other cloud native tools to do that, like your C3M or Palo Alto's Prisma Cloud and such, that can act on premises at times as well as on cloud and give you full capabilities for all of that. So you can try to use some of those controls from there. Anyone has anything else that they find interesting or they use controls in the past and that's been useful for it?
Hey, Darpin, could I have you back up one for a moment?
Sure.
Yeah, I guess I was just kind of going from the comments that were in before from CL as far as the opportunity to clean house, and then as you move through whether it's access policies or controls or anything like that, I'm just wondering how much sanity checking or house cleaning there is for order of operations, because I've actually seen conflicting policies, I've seen conflicting access lists, I've seen multiple owners with conflicting things, and team A is doing whatever it is they were told to do, and team B is doing whatever to do, and they're actually opposing one another. And it's that efficiency, it's that self-inspection. It's easy to add, but rarely do we subtract.
Yeah. And even like, same thing happens on-prem, right? We are saying we'll give someone temporary permissions and then we forget to remove them from it. Like forget to subtract their roles and permissions. And then we see like 6 months later that they had that access. And then someone else comes in their team and they're like, hey, this person, the team has access. I want the similar level of access for them. And that's how that net becomes wider for it. So yes, that's important, able to subtract them as well. So here is another example of like more details, how we talk about security, but then the security can be done at each level. We saw those different IaaS, PaaS, SaaS model, but all of them also comes with each level and multiple options for it. So if I use like cloud provider, let's say here I have an example for GCP, and just what are options they provide for defense in depth for it. So starting at their hardware layer itself, they have their own purchasable chips, their servers and storage. These are all because they know that this is the purpose and that users are going to use it for. They have it all customized according to use that multiple users and customers across the globe are using. For booting, you have those confidential VMs, confidential computing, or shielded VMs. So you are like putting the right credentials in place. Your booting is the right place, and like at the OS layer, if we say you have these curated images, like what we call golden images or custom images that can be created. For networking, there is tons of tools like DNS or RPC encryption, storage applications. So pretty much all layers, there are multiple options available. And some of these are done by default, that just by going to provider, you get those specific options, which you may not even have a choice to or use while on premises, maybe due to budget constraints or just like availability and affordability for that. So some of these are like services and resources that you get while moving to cloud. So there is a myth going on, or there is a notion that cloud is secured by default. So I would say that's true at some point, at some perspective. But I also agree the cloud is not secure by default. And so balancing that out, that's the important part. So when we say secure by default, we can say, okay, I have all these services and hence it's secure. But then how you configure is that's up to you. That's where I'll go with it.
Think about stories that come from Google. If you had an opportunity to talk to them who create their servers and their disks and where they buy stuff from. Because when you think about, honestly, when you're buying hardware and you're in the public space in the United States, we're a public target. And Google, oh my God, if they don't have a target on their back, oh my God, they have a target. So when they go out and buy hardware and they're buying from offshore somewhere, someone who may not be happy with the United States, you don't think that someone's going to be a bad actor and slip something in the hardware just because I got an axe to grind? You got to be kidding me. So therefore, when they get a hold of something, guess what? you said something so important, the golden whatever it is, software, disk, hardware, I don't care what it is. When they get it onshore, they rip it out. If it's on the BIOS, they rip it out. Guess what? They had the BIOS and they already checked it and they put the BIOS back on it. They took the whatever the main software is on it, they ripped it off and put it back on because they checked it before they put it back in service. So therefore, all the basic things, for at least when I talk to Google, I have more confidence in them than I had with conversations with AWS. But you know, it's just the person I got a hold of, maybe, okay? But you don't think that these cloud providers are not thinking about your concerns right now for what they're providing as the trusted sources? Because the DoD is combing through AWS so hard because they're winning the war right now. There is AWS, Govy place. So it's totally private. It's behind a firewall. It's not really managed by AWS, but it's all the AWS software, and therefore it was provided to DoD, and therefore it's behind and not plugged into the internet. Bad for the developers who have to do it, because when they work on it, they can't get open source stuff that's not approved. Therefore, then, you know, it's very hard to get innovation inside of these things.
Definitely, yeah, agree to that. That's why, like, when you go to provider, you trust them that they must have something secure. They already vetted things for you, right? So next comes the implementation. That okay, we have all these controls and such. So how do we implement it? Various ways. First is infrastructure as code. You can code up everything so you know you have the right recipes and you can replicate them easily, making it reusable across your environments, across projects, or even across your applications for it. So you can easily automate that. But next comes CI/CD. Like, if not, doing all these tools and having this API-backed security and software makes it easy to incorporate all of these in your CI/CD pipelines, whether it's Jenkins or Circle CI or Bamboo or any of that you are using. It makes it easier to integrate them all and making it automated. And CI/CD brings me to the next point of DevOps, the developer operations here. So that's when, because we are this cloud providers, are able to provide us the development capability as well as the operations capability, like the infrastructure and all. It makes the DevOps job very easier because they're easily able to bring that development operations together in true sense for it. And lastly, with DevOps comes policy as code. You can actually have the security policy implemented as code, so you're not relying on those fat finger or those errors on the console or UI to be changed for it. So talking about DevOps, just I'll go briefly over this, like in the interest of time, and we're coming to towards the end. So DevOps, we start with like planning, coding, building, testing, and then comes release. But again, it's an infinite cycle, as we all know, that once you monitor and changes, again, you need to reiterate upon that model and develop that. In terms of AWS or any cloud provider, that would be something like you create a code, Git repository, put it on your storage or S3 in AWS, and create a code pipeline that's AWS's CI/CD platform for it. And then you create stack, you deploy your Lambda functions, someone needs to go and approve it in CD, and then you deploy and execute the change, right? And if you're using Terraform, the infrastructure as code platform, then same thing apply. You plan and apply, and infrastructure is deployed easily with Git. But then the next part comes the DevSecOps. So making security as part of the DevOps pipeline. And that brings us to a whole new concept where we introduce security from ground up at each and every level and stages of our CI/CD for it. So similarly, our previous example would improve here as like we're adding a validator in between. And once I'm committing something to code or Git in there, after that, it gets validated. You introduce scanning for infrastructure itself within your pipeline for it. And then you deploy it. And then once you deploy it, you use something like a security command center where you visualize it constantly, whether something is changing or not. In terms of Terraform, we have Sentinel policies. So even though you are doing your DevOps, you are now including security as part of it and making DevSecOps. So even though this cloud comes with its own challenges, it makes it easier for us to create it and actually add some information and validation for that. Similarly, you can use, like someone mentioned CrowdStrike earlier, you can use like all of those similar tools at each and every stage of your CI/CD pipeline. Whether you're building, you can use a Python, Gradle, Anaconda for Python and all that, making it secure, using certain principles, or frameworks, automation, testing, and again, all these different levels and stages. There are tons and tons of tools and products out there that they can use. But for DevSecOps, it's important that you keep focus, and cloud makes it easier, as most of these tools and products you see on the screen here allow some kind of cloud version. And because you're on cloud, it makes it easier for you to adapt to them as well. Any questions on there? So we saw some of the benefits of cloud and the focus, how we can change it and such. But then in the beginning, someone also mentioned some of the challenges that they face while moving to cloud or that comes with it. So I would like to briefly just introduce what I feel are the biggest challenges that I've seen like everyone facing, and different ways that they've actually solved it, or the tools that these providers provide to solve those challenges. First is lack of visibility and control. Because we have all these granular permissions, like multiple services available, there is no like single way to control it. Because in IAM, as Peter mentioned earlier, you have this 200 plus permissions, and you need to make sure that you are able to see all of them, who's using what. And that's like missing from a lot of providers right now, and like which we don't see it easily. Other is understand if they're configured properly, whether you're given something right permissions, or so that when you go in prod and you have this like 12 a.m. midnight deployment for your production, you don't find some errors at that time if you understand it beforehand whether the configuration is right or not. Transparency and accountability, need to make sure like you have that transparency there, that who is doing what. AWS right now has more than 264 services on their cloud platform available. And there is no way that as a single company, you're going to be using like all of them. So you do, and if someone, they have services for like satellite station, like ground station, and you definitely don't want any like random employee of your company to go and use that service and just deploy some configurations on it. So that's why you need that accountability and transparency in that place. And the last comes inability to detect threats. Because your surface is just increased now, you have to struggle through, you have to make sure that you're able to detect threats or issues at all levels, whether it's service level itself, availability, reliability, and capability, or whether it's your configuration or your account, uh, your settings on the service itself, or something on premises, your connectivity. So you need to be able to detect all of those threats there. So these are some outstanding challenges that companies usually have, and there are different ways they try to solve it. Right. Anyone wants to add anything else that they faced? Any other challenges they would like to add as a major classification? Something?
Not a classification, but think about it. The inability to detect threats. All right, now I want you to detect any and all administrators of the system who have created abnormal activity, because I don't trust every one of them. If I can't trust your computer when you connect to the system, I don't trust any administrator on the system as well. And therefore, normally when I was inside of a company, I had to have an administrative email for someone to change an administrative role and a traceability to change, example, firewall, to do that. Without that email, someone was going to be fired. And right now in the cloud, it's willy-nilly. Who knows what an administrator is doing? Who knows who's changing this? You're lucky if, when you talk about all the various capabilities within a cloud provider, if anybody even knows what, if you can list all 200 something plus of them, if you can list all of the capabilities of everybody has on every access of every admin role policy for every resource on the system. And therefore, then I want you to tell me what's changed from yesterday to today.
Yep. I mean, there are tools, so it's out there, right? So I was going to talk about more at the infrastructure level and endpoints, and well, also for threats, right? When you're talking about threats, they can be covered at all levels. So there are some ways we can mitigate it, for example. In the interest of time, like we don't, since we are like only have 7 minutes left, I would quickly go over like different ways how you can improve that security at all levels. So starting with infrastructure, you can have like firewalls built into VPCs or a hybrid connectivity. So your traffic is not even going through the internet, as all private connections and TLS and such. Or the endpoint level, when I'm talking about something like CrowdStrike or other endpoint users, like I mean, I would say SolarWinds, but I want to say as a name or solution right now. But you can have all those configurations like just in time or for enough access, and you allow someone to do it using those VDIs, right? Where VDIs, you create something, and then once your work is done, you get rid of that VDI machine pretty much and spin up a new time every time. So use like AWS workspaces for your end users. So there's nothing like constant or nothing permanent to be used for it. For DDoS, you can have like built-in management like AWS WAFs or AWS Shield or those managed services that you use. Right. I wish we had like more time to actually go in more details, but I want to maybe like leave some time at the end for questions as well. And so I'm going to quickly like go over this. Trusted software again goes by like CI/CD, where you need to know that for open sources, scan those, know where it's coming from. What if there's something malicious code inside? You need to be able to know. So that's what is the important part. Only obtain software from known and trusted sources. What Peter mentioned earlier, that going to Google and knowing them, they have already vetted certain things, that increases your confidence in it. All right. So try to go to trusted sources for it. Understand compliance. Understanding this is one of the biggest things. These are the GDPR and like the California Protection Privacy Act, FedRAMP for government. That's one of the most important, something that I'm working on currently as well for some of our clients. So understanding that, so understand those laws and how your providers and those cloud providers make it easy for you to get that. So security is also like understanding this compliance and makes understanding this makes it easier for you. Identity and access control, all we talked about IAM earlier, that all also helps in mitigating some of those challenges that we saw earlier in terms of cloud adoption for it. Data security, use encryption, like key management system, you have the DLP capabilities, which you may not have like locally on premises or for your own users. For our SMBs, it might be hard to do it. So rely on cloud providers for those services. Use the context aware access. So I know in the beginning when we started, someone asked that can we like pinpoint on identity and context aware access, that how to create those access policies. So that's some of these providers make it easier for you. But then also again, it's up to us and how we create those policies. If we talk about that, we'll take one full session. In fact, we can speak about this access policies, configuration and such. Maybe we can schedule something in future to just have full meetup discussion just on this part as well. But yes, this is an important concept in these data access. Managing inventory, so knowing what's there, what you have in there. So when we said lack of visibility, so there are like active inventory checks that you can do either using your infrastructure as code, making sure everything is deployed via code like Terraform or AWS CloudFormation, Google Deployment Manager, or even Pulumi, and like that. So that makes it easier to actually see what's in the system and then configure it. Logging and monitoring, extremely important, making sure what's in the system, you're able to log them and monitor changes and notifications coming out of there. And because it's all API level, you can manage it easily and put it into your SIEM like a single instance of Splunk per se, or something like if you're using other providers like Sumo Logic to generalize and aggregate your logs for it. Example of how you can do it in AWS. So once you set up the account in AWS, you can start doing from the beginning itself, where you have a special logging account and your security account where everything gets shared and all the security and logging components from other projects and other accounts come to your single security account to make it easier for monitoring here. And lastly, I want to say like how you can actually see all this in single pane of glass. So AWS is AWS Security Hub, where you get some of these built-in checks and built-in services that you can check on a single pane of glass or a single page, where it does like continuous monitoring and alerting for you, and also like runtime. So it covers your runtime and also deploy time security for it. So you can configure some of these. Similarly, in Google, you can have Cloud Security Command Center, where you can actually fix some of the configurations that are misconfigured. You can get the threat detection alerts directly that this needs to be changed or something is malicious. So this cloud providers makes it easier in that case. So when we saw earlier, in order to detect threats, so these are new services and improvements that are constantly improved by these providers, makes it easier to also detect and see on that. And lastly, my last slide, I want to leave you with some of these resources where we talk and learn about more security. On AWS, everything is done on single page security. Google has everything on security best practices. And also the foundational guide. It's a 40-page document that lists what should be your foundations over security and how to implement them. What can you do with it? So this is the last thought I'll have to leave you with. I know we have 2 minutes remaining. Feel free to reach me out with any questions or any comments on it. I'm open for any like even chat if you want to do a coffee chat or anything. Thanks everyone. Time for questions and comments.